Hello everyone. Today we're going to do section 3.5, transformations of graphs. This is section 3.5, everybody, transformations of graphs. Okay, section 3.5. We're going to begin with the parabola. The basic parabola is this: f of x equals to x squared. This is the basic parabola. We can graph the basic parabola. Let's make a table. X and f of x. Let x be 0. Let x be 1, let x be 2, let x be 3. Let x be -1, -2, and -3. Okay? If x is 0, then 0 is squared according to this basic parabola. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. That's a 9. -1 squared is 1. -2 squared is 4. And -3 squared is 9. Okay? Now we can graph this basic parabola. Graphing it. So here is the x-axis. And here is the y-axis. So when x is 0, we get 0. When x is 1, we get 1. X is -1, we get 1. Yes? X is 2, we get 4. And x is -2, we get 4. Okay. X is 3, we get 9, 4, 5, 6, 7, 8, 9. X is 3, we get 9. And x is -3, we get 9. Please note that this parabola, the y-axis is where you pass the blade. Take a blade and pass it through the y-axis. Note that you're cutting the parabola exactly in half, which is the y-axis. But what I meant to say is that the y-axis is x equals 0. X equals 0 is the y-axis. X equals 0 is the axis of symmetry. So therefore, the axis of symmetry is x equals 0. And x equals 0 is the y-axis, okay? Please disregard what I said earlier. This is the y-axis. There we go. Okay. Now, so therefore, this is the basic parabola. The basic parabola. If we go to the book, we notice that in the book it says that you can shift this parabola to the left or to the right. You can shift it up and you can shift it down. Okay? Note, if you want to shift this parabola sideways. Note, if you want to shift it sideways, on page 238 of the book, it says, let f of x be a function. So f of x is a function, page 238, and then it says, and let C be a positive number. And C is a positive number. This is what they say. If you want to shift this graph to the left, if you want to shift this graph to the left, just do this. Take the function and take x and add c. This is going to shift this parabola to the left. Example. Watch this. This is an example. Example. Let's suppose c is 2. So we have f of x plus 2. Well, let's apply this to this parabola. Note, let's replace this x plus 2 there and there. So therefore this equals to x plus 2 quantity squared. You can take a table and graph this parabola. Sure you can. You can make a table and graph this parabola. We're going to do that. Okay? Let's make a table and graph this parabola, okay? Watch this. Here's x. And here is x plus 2 squared. Watch this. Let x be, let me go here. Let x be 0. Let x be 1. Actually, -1. Let x be -1, -2, -3, -4. Watch what happens. Let x be 1 there, let x be 2. Watch. I am graphing x plus 2 quantity squared, okay? Which is represented by this. If x is 0, this will be 0 plus 2. 0 plus 2 is 2. 2 squared is 4. If x is 1, that's 1 plus 2, which is 3. And 3 squared is 9. If x is 2, that's 2 plus 2, that's 4. And 4 squared is 16. If x is -1, -1 plus 2 is 1. And that 1 squared is 1. Okay? If x is -2, that's -2 plus 2, which is 0. And 0 squared is 0. If x is -3, what's -3 plus 2? -1. And -1 squared is 1. If x is -4, what's -4 plus 2? That's -2. And -2 squared is 4. One more. -5, I'm sorry. Let x be -5. If x is -5, -5 plus 2 is -3. And -3 squared is 9. Okay? Watch what happens when we graph this parabola. Okay, let me see if I have a blue color. Okay, give me a second. I don't. Okay, so I do not have a blue color. No problem. We're going to graph this now. So watch this. When x is -2, y, or this is f of x plus 2. That's f of x plus 2, which is right there. If x is negative 2, x plus 2 quantity squared is 0. If x is negative 2, 0. See that? If x is negative 1, we get 1. If x is negative 1, we get 1. Yep. If x is 0, we get 4. If x is 0, we get 1, 2, 3, 4 right there. Okay. If x is 1, we get 9. Look. If x is 1, we get 9 right there. So far we have this. Look. Look what happened. Guys, look what happened. Okay. This side of the parabola shifted twice left. I'm not done, okay? Let x be negative 3. Negative 3, when x is negative 3, this is 1, look. X is negative 3, we get 1. Okay? When x is negative 4, we get 4. X is negative 4, and we get 4. Right around there, approximately. Okay. If x is negative 5, what do we get? 9. Approximately there. So look what happened. Okay? So, what happened? If c is 2, x plus 2 becomes x plus 2 quantity squared. This shift the basic parabola 2 units to the left. Okay? So everybody, if you take a function and you add c to the argument, x is the argument. Take a function, and if you add c to the argument, x, that's going to shift the function to the left. So this is a shift c units left. And here's the example. Example here is the argument plus 2. If we're talking about the basic parabola and you add 2 to the argument, right here, you add 2 to the argument, then this is the new argument x plus 2, and that's being squared. Okay? What did this 2 do to the basic parabola? Here's the table. It seems to me when you add 2 to the argument in the parabola, this tells me it's a parabola right there. That means it shifts the basic parabola, this parabola, 2 units to the left right there. You see that? This table is graphed right here. Okay. All right. Okay. I need room. Okay, so I have to erase this. So I'm going to do another one. Watch what's going to happen, guys. Okay. Watch the following. Okay, watch this. I'm gonna take this parabola f of x. Watch this, everybody. I'm gonna take another example. Example 2. I'm going to take this parabola, f of x, and I'm going to, that's the argument, right there, x is the argument, and I'm going to subtract 3 I'm subtracting 3 from the argument in the parabola f of x. Well, if this is a parabola, it refers to this, f of x, note this parabola takes the argument and squares it. So this is going to take the argument, x minus 3, and square it. Okay. And my question to you is this. What is this new argument, x minus 3, what is that going to do to the basic parabola? That is going to shift the basic parabola 3 units to the right. So when you shift horizontally, you shift in the opposite direction. When you shift vertically, you do not shift in the opposite direction. Okay? I can show you. I'm going to do a table for this one again, because I want to convince you. I don't know where my blue is. Where is my blue? Oh, here's my blue, guys. Watch what's going to happen. I'm going to make a table. So here is x. And x minus 3 squared. Okay. All right. So let x be 3. Let x be 2. Let x be 2. Let x be 1. Let x be 0. Okay. Let x be 4. Let x be 5. And let x be 6. Okay. Watch what's going to happen. Watch what's going to happen to the basic parabola. Okay. So if x is 3, 3 minus 3 is 0, 0 squared is 0. Okay. If x is 4, 4 minus 3 is 1, 1 squared is 1. If x is 5, 5 minus 3 is 2, 2 squared is 4. If x is 6, 6 minus 3 is 3, 3 squared is 9. If x is negative 2, if x is 2, 2 minus 3 is negative 1, negative 1 squared, 1. If x is 1, 1 minus 2 is negative 2, negative 2 squared is 4. If x is 0, 0 minus 3 is what? Negative 3. Negative 3 squared is 9. I'm going to graph this now. I'm trying to show you guys that when you subtract a number from the argument, when you subtract positive number 3 from the argument, that is a horizontal shift in the opposite direction. 3 units to the right. Okay? That's what I'm trying to show you. Watch what happens. If x is 3, we get 0. 3, we get 0. If x is 2, we get 1. 2, we get 1. If x is 1, we get 4. 1, we get 4. See that? If x is 0, we get 9. X is 0, we get 9 right there. Okay. If x is 4, we get 1. X is 4, we get 1. If x is 5, we get 4. X is 5, and we get 4. If x is 6, we get what? 9. X is 6, and we get 9 right there. And look, here is our new parabola. Guys, you understand? Does this make sense, everybody? The new parabola. Look, this here is f of x minus 3. It shifts 3 units to the right. It shifts the parabola 3 units to the right. Okay? Very good. Okay. So therefore, let's make a few statements now. I think we're ready. Okay, everybody has this, right? I gotta erase it, I'm sorry. I have no choice. You guys can go back and reverse the video and look at it again, okay? So it seems to me that for any function f of x, and c is a positive number, x plus c in any function is a shift c units to the left. F of x minus c is a shift c units to the right. Yes? Okay. Note, when you're adding, it's to the left. When you subtract a number, a positive number, it's to the right in the opposite direction. Watch this one. F of x, note, I'm not adding to the argument. X is the argument. I'm adding to the function. Plus c. Note the difference, okay? Here I'm adding c to the function. Whereas here I'm adding c to the argument. Okay? This is a shift c units up. Up. Can I give you an example of that? Sure I can. Watch this. Take for example f of x plus, let's say plus 4. Plus 4. Note, I'm adding 4 to the function. If the function is the basic parabola, this one here, if it's the basic parabola, this equals to the following. F of x is x squared plus 4. This is going to shift the basic parabola 4 units up. Okay. Make a table, and you'll see that's what it does. Here. X and x squared plus 4. This is the basic parabola plus 4. Please note the difference, okay? I should say plus 2, because I'm running out of room. If x is 0, what's 0 squared? 0. Plus 4, 4. If x is 1, what's 1 squared? 1. Plus 4, 5. If x is negative 1, what's negative 1 squared? Negative 1 squared. 1. Plus 4, 5. If x is 2, what's 2 squared? 4. Plus 4? If x is 2, what's 2 squared? 4. Plus 4, 8. If x is negative 2, what's negative 2 squared? 4. Plus 4? 8 again. Okay? All right. Okay? So let's graph that one out. If x is 0, we get 4. Look. If x is 1, we get 5. If x is negative 1, we get 5. You see it? X is 1, we get 5. 1, 2, 3, 4, 5. If x is -1, we get 1, 2, 3, 4, and 5. Do you see it? If x is 2, we get 8. If x is 2, we get 8. Right there. If x is -2, we also get 8. Right there. And so we're getting this parabola now. So what happened? When you add 4 to the basic parabola, that shift the basic parabola 4 units up. That's what this is saying. And this applies to any function. Okay. Here we go. That one. By the way, well, let me finish this, okay? Let me finish that. So I'm running out of room. So let me erase this. I need the room, okay? Okay. So you guys tell me what's f of x plus or minus c. This is a shift c units down. Okay. All right, very good. Excelente. Okay. And this can be applied to any function. Any function. Okay? All right. So let's get some examples now. Okay? Don't forget. Oh, by the way, here's what I need to say. You see this f of x minus 3? The axis of symmetry has changed for f of x minus 3. It's the blue one. You guys tell me, where is the axis of symmetry? The blade. Where you pass the blade and cuts the parabola exactly in half. Where is that? It's this line, look. I call it a blade, this line, because that's where you pass the blade and it cuts the graph exactly in half. Can someone give me the equation for the blade, or the axis of symmetry? Yes. The axis of symmetry is axis of symmetry is x equals 3. The vertex is where? Vertex is at x equals 3, y equals 0. So the axis of symmetry for this one is x equals 0, which is the y-axis. I made a mistake earlier, okay? The axis of symmetry for this basic parabola is x equals 0. I wrote it earlier, which is the y-axis. The axis of symmetry for this one, look, for this one, is also x equals 0. What is the axis of symmetry for this one? The axis of symmetry for this one is x equals -2. Axis of symmetry, x equals -2 for that one. Very good. Okay. This can be applied to any function. Okay. All right. Unfortunately, I need to erase all of this. So I will. Sorry, taking so long. Okay, don't forget this basic parabola, okay? Okay. All right. Can we graph this? Can we graph, let's call this g of x. G of x equals to, watch this, x plus 1 quantity squared minus 3. Can we graph that? Do we recognize it? Well, it seems to me that this tells me, this power of 2 tells me that we have a parabola. This power of 2 tells me that we have a parabola. Okay? So this is the parabola that we graphed earlier. This is f of x equals to x squared. Yep. And this 1 is being added to the argument. So this 1 tells me that I'm going to shift the basic parabola, right there, that's a basic parabola, 1 unit to the left, 3 units down. Okay. Let's graph it. One unit left, 3 units down. 1 unit left, 1 unit left, and 3 units down. And that's the new vertex. The vertex is, take the opposite of this, the vertex is -1 comma -3. That's the vertex for this parabola. Note, I'm applying that. Yes, I am. This is f of x equals x squared, except that I call it g of x, but that's fine. Okay. By the way, if you wanted to call this, if you wanted to use this notation, if you want to use this notation for that one, okay, I'm going to use this notation. It seems to me we have x plus 1, okay? So this is the basic, take f of x, okay? Add it 1 minus 3. If we're saying that f of x equals to x squared, you apply this to that, and we're going to get this new graph. Okay? So the vertex, 1 to the right, 1 up, 1 to the left, 1 up. Twice to the right, 4 up. twice. 1, 1, 2, 3, 4, up. Twice to left, 4 up. And we're getting that. Whoa. This is the graph for that, for g of x. And what did I do? I took the basic parabola, shift it 1 unit left, 3 units down. Okay. And here we go. Okay. Now, like I said, we can apply this to any function. Any function. Okay, all you have to do is recognize. For example, consider the following function. Consider f of x equals to the square root of x. Can we graph this? Sure we can. We can graph that. Make a table. Here's x and the square root of x. Okay? Let x be 0. Let x be 1. Let x be... You gotta pick nice, smart values for x here. Let x be 4. Let x be 9. Let x be negative 1. What happens if x is negative 1? That's the square root of negative 1. For graphing purposes, this does not exist. Doesn't exist. It's a complex number, okay? It doesn't exist if you're trying to graph it, okay? If x is 0, what is the square root of 0? 0. If x is 1, what is the square root of 1? 1. If x is 4, what is the square root of 4? 2. If x is 9, what is the square root of 9? Let's graph it. Here's the x-axis. My y-axis is a little bit crooked, but that's fine. Here's the y-axis. And now we're gonna graph. Note, if x is negative 1, it doesn't exist. No function is there. But if x is 0, look, we get 0. If x is 1, we get 1. If x is 4, we get 2. 2, 3, 4, we get 2. If x is 9, we get 3. 5, 6, 7, 8, 9, we get 3. And we're getting this graph. Right, that's what it looks like. Watch what I'm gonna do, okay? Watch what I'm going to do. I'm gonna take this function and I'm gonna subtract 3 from the argument. I did it to x, and I'm gonna add 2 to the function. Okay. what is that going to do? This f refers to this, okay? We're talking about this one. Okay. If you were given the equation, it would look like this. The square root of x minus the expression, it would look like this. Square root of x minus 3 plus 2. That's what it would look like. What does this, you can call it y if you want to. If someone said to you, can you graph that y? You say to yourself, wait a minute, this is the basic square root function. 3 units to the right, 2 units up. Okay? Okay. So that y refers to this square root, which is right there. 3 units to the right, 1, 2, 3, and 2 units up, right there. Okay, so this point moved there. The next point, this one, this point, 3 units right, 1, 2, and 3, and 2 units up. This point right here, this one, 3 units right, 1, 2, and 3, and 2 units up. That's what it looks like. This point, 3 units right, 1, 2, and 3, and 2 units up. And so therefore, this is y, you may call it y if you want to, the square root of x minus 3 plus 2. Okay. All right. Now, if you notice, here we have the following. It says, on page 243, every time you multiply a function by a negative, that is a reflection across the x-axis. In other words, here is the x-axis, and you put a lever there, and that's you grab the lever, and as you turn the lever, you are reflecting across the x-axis. This is going to come down this way. We call that reflection across the x-axis. And that's right there. Okay? When you multiply by a negative. Okay. All right. So let me give you an example, okay? An easier example, okay? Watch this. Whenever you multiply a function by a negative, that's reflection across the x-axis. For example, if you have f of x equals to, I'm going to say x squared. Okay, we know what this is. This is the basic parabola. Right there. That's x squared. When you multiply this by a negative, and this by a negative, that's a reflection across the x-axis. What you're doing is you take the lever, grab the lever, and you start turning 180 degrees. And this is gonna begin to come down, okay? And it's gonna look like this. Note, this is negative x squared. You may call it, note, it really is, if this is f of x, if this is f of x equals to x squared, this must be negative f of x. I'm talking about this f of x, okay? So that's why in the past they told us that whenever there was a negative in front of the quadratic term in a parabola, it opened down. That's why. Okay? Let me give you an example. Let's graph the following. Let's graph, everybody. Let me erase this so we don't get confused. We're graphing, everybody. Let's graph negative x minus 2 quantity squared plus 1. You may call this y if you want to. There it is. Okay. Guys, that tells me that we have a parabola. Reflection across the x-axis, so it's going to open down. The vertex is at 2, 1. This is the basic parabola. Opens down. Vertex is at 2. Vertex 1, 2, and 1. And it's going to open down. Okay? How do I know that? Because, hey, wait a minute. Because there is a negative in front of the parabola. That's why. Okay? And so the vertex here, the vertex is where? At 2, 1. What's the axis of symmetry? Axis of symmetry, what is it? X equals 2. And it opens down. Okay. So 1, 1 down. 1 to the right, 1 down. 2 to the, from the vertex, 2 to the left, 4 down. 1, 2, 3, and 4 down. 2 to the right, and 4 down, approximately there. Okay? And we have this. And that's going to be there. Very good. Excellent. Okay, good class. Let's see what else they have here. Okay. All right. Okay, I'm going to stop here, guys. Okay. And I think now we could do some of the homework. You could do the homework from section 3.5, okay? Section 3.5, you can do the homework now, okay? Thank you very much. Have a nice day.